Hi everyone and welcome to my Go course. Today we're going to talk about constants in Go. So in the previous lessons we talked about variables, and the variables you can think of them as containers which can store values of a particular data type. And constant is a similar concept, so it's also a container holding a value of a data type, but the difference between constant and variable is that the constant value never changes, it will never change, and Golang guarantees that the value of a constant is known and evaluated during the compilation. So in the previous lesson, we defined our variables using the var keyword and following by the name of the variable and the data type. And uh, the initial value it wasn't necessary to assign the initial value always, so we could just reassign the value of a variable because every variable is assigned a zero value implicitly if you do not initialize it explicitly. With the constants, it's a little bit different. You can define a constant by using a const keyword followed by the name of a constant and its data type and the value. So the initial value and actually the actual value of a constant, is mandatory because um, as I mentioned before, the value should be evaluated and should be known during the compilation, and it never changes. Go guarantees this. So this expression is invalid. I cannot do this. I cannot change the value. Even if it's the same, I cannot change it. But I can use it in my code, but I cannot change it. I cannot modify it in any way. And for example, if I decide to delete it, to delete the assignment, and then Golang compiler will complain because I'm missing a constant value. So in case of variables, if we do not initialize a variable, it will be assigned a zero value. For integer types and for float number types, it's a zero. For string, it's an empty string. For struct, for example, it's an empty struct. And for pointer, it's nil, and so on. But it doesn't work with constants. So constants should always be initialized with some values because this is the essence of a constant. And so I'll show you something else. Actually, there is a syntactical trick, and this is a pretty useful feature because you do not always want to have declare your variables within a function scope or specifically within the main function. So sometimes you have several functions and you want to access the same variable from within those functions. And that's why you can just declare a variable on top of your on the top level of your source code file, and then you can access it um, in the function scope like this. And you can also declare b, for example, and this is how it works with this declaration. And Go syntactically, there is also syntactical sugar for this kind of case where you have multiple variables or constants. You can actually write a var keyword only once and use parentheses, open parentheses, and close them. And in this way, you can define multiple variables, like even c of a different type. And sometimes you can even uh, explicitly write the data type of this variable. But in the variable case, it's not always necessary because Go, if you use the literal, Go compiler will guess the data type of this variable. So the same you can do with constants. For example, const d is equal to 30. And um, as I mentioned before, the value of a constant should be known uh, during the compilation. So the the way you initialize a constant is by using a literal, or you can use, for example, another constant. Like if I have, let's say I have a constant, let's open parentheses because I would like to define multiple constants, e, and I want it to be like d plus 2. So this is a legal expression, and the compiler will not complain because in this case, the value of this constant will be evaluated as a sum of d, which is also a constant, and 2. But if I decide to use, for example, variables for this, like a, for example, let's say a plus b, it's not a valid expression for Go because um, this value cannot be evaluated during the compilation because we're using variables here. So we cannot use, for example, a function call. Let's say um, if I use a variable in a function call and the result of this variable will be also a variable, then it's not a valid expression. But if I use d, it also won't work actually. But I can use, for example, predefined constants. I can assign the predefined constants, and this is a legal expression, of course. Um, Actually, this is e. So, and let's print it. Go run main go, and you can see this math package has some predefined mathematical constants. They are approximate values. So in this case, we're using the exponent constant, and this is it. It's approximate value. So what else can we do with constants? Syntactically, there is like I'll delete this code, clean a little bit. So syntactically, there is another beautiful feature. For example, if you have multiple constants that have different names, let's say a is equal to 56.6, and you have b, which has the same value, you can actually skip this assignment. And if you check the value of a and b, let's print those, a and b, I'll print them out. They both have the same value. This is kind of shortcut if you want this b constant be assigned the same value. And let's say c is equal to 45 and d is equal to the same. So c, d, and if we run this, we'll see that c and d, both of them have same value. And there is even a special kind of operator in Golang, which is called Yota, which can assign your constants sequential values. Sorry. So this is it. I'll delete this one. This is syntactically how you use it. So you can optionally you can assign a data type, or you can skip it. I'll tell you a little bit in a moment what's the difference with this. And I assign it a value using the Yota operator, and let's print them out and see what happens. So Yota basically generates values sequentially. So for A, it generates the value of 0, then it goes and generates the value for B, which is 1, then 2, and 3. And we can affect it, for example, by using some arithmetical operations and like this, or even multiplication, for example. One more, sorry. So multiplication, and in some cases, you may also want to use the shift operator, the bitwise shift operator. And let's see what the result will be. So 1, 2, 4, 8. And there is also a trick. For example, I want my constants to have only even values like 2, 4, 8. and I would like to skip this first value. There is also a syntax for this. We can use this underscore, which means basically skip this value, and we'll just copy and paste this here and run. And as we see, the 2, 4, 8, 16, all of my constants have even values, and we skipped just this constant. So this underscore means that you cannot reference this constant in any way, and you cannot use it in your code. It's just to skip it. Um, in the next lessons, I'll show you the use cases, why it may be useful. But for now, let's move on and let's see the difference, for example, between a normal constant and an untyped constant. So there are two types of constants, and some of so two types of constants, untyped and typed constants. So for example, if we write explicitly here and the int data type and assign it a value, then if we print it, if we see this constant has an integer data type, which is obviously, but B and D will and C and D will copy all of this, and they will have the same data type. But let's assume I'll remove those constants. We have B constant. I'll just assign it with the value of hello. So it will be a string constant, and its data type is untyped string. So what is the difference? And the difference is that, for example, like you can work with them in the same way, but the Golang compiler gives to the untyped constants much a bigger precision. For example, when working with numeric values, um, for integer type, for an integer type constant, you're limited by the amount of bits and bytes, um, by the constraints of a particular data type. But if you have a constant, you can have like any big value or any um, floating point value of any precision, and it will be evaluated by Go compiler very precisely. So you can have a constant which has a really big value, and a Go will treat it precisely and without overflow. So the type of it is untyped int, even though if we take like if we take just a normal int can store only 4 bytes of data. So if I write here the int, it says overflow, so it cannot be used because it's too much data for 4 bytes. 4 bytes um, can store maximum. The maximum value for int is, for example, about 2 billions and something. But if I delete this and I use untyped constant, then Go treats it well. And this is the difference. This is the biggest difference between typed and untyped constants. And it's also important, for example, when we use floating point numbers, let's say, because it's really hard, you see the amount of um, the comma, the point, the amount of numbers and after comma, and this is you really need a high precision for this. So if I just write float 64, okay, it still works, but if I give it a bigger precision, probably it won't work because it will lose a part of this fraction. But uh, when using an untyped constant, Go will give it a bigger precision. So this is the biggest uh, difference between typed and untyped constants. And this was it about constants in Go. And hit the like button if you liked the video and subscribe to my channel. And thank you for watching. See you in the next one.